Hey guys, all right, this is example 3 in our hyperbola. This is our application part of our hyperbola. Two recording devices are set 2,400 feet apart with the device at point A. Okay, so point A device is to the west of device at point B. At a point between the devices 300 feet from point B, a small amount of explosive is detonated. The recording devices, which are A and B, record the time until the sound reaches each. How far directly north of point B should a second explosion be done so that the measured time difference recorded by the devices is the same as for the first detonation? Okay, so normally when you have recording devices, those are the two foci of a hyperbola. So when you have foci, I like to put them on a coordinate plane. So you really have recording A and recording B. And I like the center, the origin, to be in between them. Recording A and B have the distance between them would be 2,400 feet. So what that means is half of it would be 1,200 feet, okay? So the total would be 24. So this is also 1,200 feet. Now, the first explosion went off at 300 feet from device B. So don't hold me responsible for the distance or accuracy of the distance. I'm just sketching it out. So the first explosion, it says, hey, you know what? The first explosion is 300 feet from point B. Now the question is, and then you have two recording devices, okay? So when the first explosion went off, recorder B is going to get the signal quicker than the recorder A, because recorder A is a lot further away. Now the question is really saying that, hey, how far north, okay, how far north of the point B should a second explosion be done so that the time difference recorded by the devices is the same as the first explosion? So if I were to go north of B and set off a second explosive, the question is, how far north should that first recording, the second explosion be done so the time difference is the same as the first one? So this is really a hyperbola. Anytime you have a explosive going off or a transmitter of aircraft or boats, you are now dealing with hyperbola. So the differences we want to know, well, okay, so that's explosive being recorded by device A and being recorded by device B. We like to know how far north should we place it so the time difference is the same as the first explosive. Okay, so as you can see, the first explosive, it's the vertex of this hyperbola. Okay, so the vertex, what that means is the vertex gives me an A value. A value, okay, is from the center. It's from the center to the vertex. So my goal is to really get an equation of this hyperbola. Well, I also should find C value, okay? Anytime you have recording devices, these are the foci. Okay, so this is focus 1, and this recording device B is really focus 2. Okay, so I can find C value. The gap or the distance between the two foci would be 2,400. 2,400 equals 2C. So that means a C value will come out to be 1,200 feet. I can also find A easily using my Pythagorean theorem. A in this one is, A in this one I can easily find because A is from the center to the vertex. Well, let me get a different color. Would you agree that here's the center? The vertex is right here. Okay, so I can find that A distance by saying A is 1,200 feet minus 300 feet equals to 900 feet. And the reason I got 300 was because 300 was the first explosive. Remember, it says 300 feet from recording B. So I got A. Now I just need to find B. The reason I need to find B squared is so I can write an equation of a hyperbola. So B squared equals C squared minus A squared. B squared equals C squared was, excuse me, C was 1200, so I need to square that. A was 900, so I need to square that. Plug in my calculator, I got 630,000 feet for B squared. Well, so now I just need to write an equation of a hyperbola. Hyperbola is going to be x squared over something plus y squared over, I'm sorry, not plus, minus. Okay, minus y squared over something equals 1. Well, as you can see, this is opening horizontally. So what does that mean? That means what? Which one gets a squared if it opens horizontally? This one gets an a squared, and this guy gets a b squared. Okay, well, a squared, I didn't really work that out yet, but I know a. A was 900, so now this is x squared over 900 squared is going to be 810,000 minus y squared over, I already worked out b squared, 630,000 equals to 1. I'm really just looking for this second explosive right here. I know the x location. The x location is 1,200 feet. I just don't know how far north I should put it from recording B device. So I just have to plug in 1,200 for x. From here, 1,200 square all over 810,000 minus y squared over 630,000 equals to 1. So with the use of my calculator, I can solve for y. Y came out to be 700. So the second explosive, okay, the second explosive should be 700 feet north of device B. And that's exactly how we're supposed to do that one. And again, anytime you have the recording devices or the transmitters, if we're talking about boats or airplane, then those are going to be your foci. And this is the end of example 3 recording.